Welcome to this session. This session will discuss the last number system, the so-called the hexadecimal system. And these are numbers to base 16. So we say this system has many computer applications. And then it uses the following characters or symbols. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But 10 is written as A, and then B, C, D, E, and F. So these are the characters that are used in this number system. And then the place values in this system are powers of 16. The place values in this system are powers of 16. So let's do some examples. So remember that the number 10 in this hexadecimal system is represented by A, 11 is represented by B, 12C, 13D, 14E, and then 15F. So examples. Convert into decimal system given the number 2A 7.3E 2 base 16. Now solution. As usual, just write the digits 2A 7, 3E, and then 2, and then write place values. Because now this is to be 16, so you write 16, write 16, write 16, write 16, 16, and then 16. And then you begin this decimal point here. So this is 0, this is 1, this is 2, this -1, this -2, this -3. Now the total value is the digit multiplied by its place value. Total value will be 2 times 16 squared. And remember, A in hexadecimal is a representative of 10. So this is the same as plus 10 times 16 power 1. And then plus 7 times 16 power 0 plus 3 times 1/16 plus E in the hexadecimal is equivalent of 14. So 14 times 1 over 16 squared plus 2 times 1 over 16 power 3. So when you work out this one, 2 times 16 squared is 512. And then so 512 and then plus 160 and then plus 7 plus 3 over 16 plus 14 over 16 squared is 7 over 128 plus 2 over 16 power 3 is 1 over 2048 plus 7 over 128 plus 3 over 16. Okay, so 512 plus 160 plus 7 plus 3 over 16 plus 7 over 128 plus 1 over 2048. We get 679. This equals to 679.2426 758 to 3 decimal places. We'll have 679.243. So therefore, the number 2A 7.3E2 to base 16 is the same as 679.243 to base 10. So that's what we have. And then example 2, if we have convert to denary form or denary system, the number 3C4.21F to base 16. Now here, solution, you just write 3C4.21F and then write place values. So because we are dealing with base 16, so just write 16, 16, 16, 16, 16, 16, and then now put in the powers. So 0, 1, 2, but here is -1, -2, -3. So total value will be 3 by 16 power 2 plus C in hexadecimal represents the number 12. So 12 times 16 power 1 plus 4 times 16 power 0 plus 2 times 1 over 16 plus 1 times 1 over 16 squared. Now F represents the number 15. So 15 times 1 over 16 power 3. This will be 3 times 16 power 2 is 768 plus 12 times 16 is 192 plus 4 plus 2 over 16 is 1 over 8 plus 1 over 256 plus 15 divided by 16 power 3 is 15 over 1496. This will give us 768 plus 192 plus 4 plus 1 over 8 plus 1 over 256 plus 15 over 1496. You get 964. 964.1325.684. Now to 3 decimal places, it's approximately 964.133, and therefore you say 3C4.21F base 16 is the same as 964.133 to base 10. And lastly, write the number. What is the decimal expansion of the number with hexadecimal expansion 2A E0 B plus 16. So what we do here, we write the solution. To A E0 B, and then place values. Now the bases are 16, so we write 16, 16, 16, 16, 16. Now because this one doesn't have a decimal, so then we are starting from here, 0, 1, 2, 3, and then 4. So total value will be 2 times 16 power 4. Now A in this number system represents the value of 10. So it will be 10 times 16 power 3 plus E represents 14 times 16 power 2 plus 0 times 16 power 1 plus B represents 11, 10 times 16 power 0. That will be 2 times 16 raised power 4. This will give us 13, 10, 72 plus 10 times 16 power 3. We get 40, 960 plus 14 times 16 squared. You get 3584 plus 0 plus 11. So 131,072 plus 40,960 plus 3584 plus 11 gives 17, 56, 27. So therefore, the number 2a e0 b to power 16 is the same as 17, 5, 6, 27 to base 10. So that is how we solve that problem. And another thing, note that each hexadecimal digit can be represented using 4 bits. For instance, 1, 1, 1, 0, 0, 1, 0, 1. This number to base 2 is the same as E5 to base 16, because one, 1, 1, 0 to base 2 is the same as E to base 16, and 0, 1, 0, 1 to base 2 is the same as 5 to base 16. And then another thing, each octal digit can be represented using 3-bit strings. Now, and then we can say, let's define what we call a byte. Bytes, these are bit strings of length h and can be represented by 2 hexadecimal digits. Now, just a small proof. You see, we said binary means base 2. Octal, this is base 8. Binary decimal means base 10. Decimal is base 12, and hexadecimal is base 16. So when you say each hexadecimal digit can be represented using 4 bits, you see this has these numbers or these systems. So this one has only a number of characters or symbols. So we have only 2 characters, 0 and 1. This one has 8 characters, 0, 1, 2, 3, 4, 5, 6, and 7. This one has 10 characters, 0, 1, 2, 3, up to 9. This one has 12 characters, 0, 1, up to 9. And then we have this. And then we have this. And then this one has 16 characters, 0, 1, up to 9. Then A, B, up to F. Now, when we say each hexadecimal digit can be represented by using a bit of using 4 bits, then for this binary, we have bit is so 1, 1, 1. So the maximum is this are the digits. So this will be power 0, power 1, power 2, power 3. So the total value will be 2 power 3 times 1, which is 8, plus 2 power 2 times 1, which is 4, plus 2 power 1 times 1, which is 2, plus 2 power 0 times 1, which is 1. So this will give us 8 plus 4 plus 2 plus 3 is 7, which is 15. And you see in hexadecimal, the largest number, you see A represents 10, this one 11, and this one represents number 15. So that is the maximum. So that's why if you have a bit of length 4, then it can fit into a hexadecimal representation. Similarly, for octal, if you have 1, 1, 1, then 2 power 2, 2, 0, 1, 1, 2. 2 power 2 is 4. 2 power 1 is 2. 2 power 0 is 1. So 4 plus 2 plus 1 is 7. And the largest digit in octal representation is 7. So that's why you're saying that each of the octal representation can be represented by 3 bits. Next session, we'll be doing examples on how to convert one digits from one number system into another number system, not just necessarily the decimal form. Thank you.